Okay, we're recording now, and why don't you, I'm just doing audio, so you can speak up.
So yeah, I've got my senior project right here.
Introduce yourself for the
my name's Rob Garone, and what I have here is a bone density monitor and photoplethysmograph. That's a blood flow monitor.
It's a photo what now?
Photoplethysmograph. Try saying that 5 times fast.
Plethysmograph.
Yeah, it's a weird word.
Okay.
Using IR light as our primary mode of measurement, our primary device to measure bone density and blood flow. So I know you can't see it, but here I have a transimpedance amplifier that has a photodetector in it. That's a germanium photodiode right there that takes in certain wavelengths of light.
Well, why don't you pretend we don't know what a transimpedance amplifier is?
Okay.
Just pretend.
A transimpedance amplifier converts a current to a voltage.
Oh.
And
that sounds like a resistor to me.
Essentially.
Okay.
A fancy resistor. It's a little more consistent than a resistor. So, if you want to see a demonstration, I'll give it to you. The other interesting facet of this is we made it wireless using Arduino, a little Kickstarter project that I looked into and got working to serve as a transmitter and a receiver from the device itself to my computer, and it prints out in a serial monitor in the Arduino IDE. So
is that Bluetooth Low Energy Protocol version 4.0?
Yes, and it's running on a Gazelle network, which is a specific type of network.
What is this Gazelle network I've heard so much about?
So a Gazelle network has a host and then a bunch of different members, or you could think of it as master-slave. And in that context, the slave begins communication with the master. The master is always pinging for the slave. And once it sees a slave, the slave will start attempting to talk to the master. The master will take the data and then send back something to say it confirms. And it sounds like one-way communication, but in this case, along with the confirmation that the master sends back to the slave, it can also send a small command or some sort of small bit of data.
Well, correct me if I'm wrong, but isn't Bluetooth Low Energy 4.0's real value the fact that it can talk directly to my iPhone so that my iPhone can be the readout for my bone densitometer and not my laptop?
Eventually, but my laptop is old, and I needed something easier to interface and program on than an iPhone.
Okay. Because if all you wanted was point-to-point communication, we don't need Bluetooth Low Energy for that.
No, not at all. No. You could do a ton of different things. But, I figured we'd go to the latest and greatest, and eventually in this device's life cycle, or the next iteration of this device, we're going to be implementing it for communication with, say, like a mobile app or the cloud or something, and you might want the Bluetooth 4.0 LE, because that's just the latest and greatest.
Yeah, now it's sounding like you've got something. So now you've got this op-amp, which you've given a fancy name to, but which is just, measuring voltage, and now you convert that into a data stream, and you send it out through Bluetooth, and what exactly is this infrared thing doing?
So the infrared thing, when you first start off with the infrared measurements, the basic components are just an infrared LED, near-infrared light LED, and this photodetector. And the photodetector essentially converts the amount of light that it sees, the photons, into a current. And that's passed to our amplifier, which converts the current to a measurable voltage that can actually be picked up by our device, our brain, our microcontroller here.
So why is a photodetector measuring bone density? Isn't it just measuring transparency?
It actually measures the refraction off the bone, the light refracted off of the bone. You can also measure the amount of absorption through the bone. So, for example, I've just been putting my finger there because it's a very easy place to get a measurement through a bone. It's very small bone type thing.
I'm holding in my hand a list of all the people in my ECE 420 class. Can it measure this and give me a bone density reading?
It could probably go right through it. It would probably saturate the device.
Oh.
So I would get a reading of 3 volts, which is our
What
RAM.
about my little zinc canister batteries? Would that give me a bone density reading?
Perhaps. I'm not completely sure.
Oh.
I have specific wavelengths just for bone that through different studies have told me that these wavelengths are the best for measuring the absorption or refraction off of the bone.
So there's actually a scientific foundation for this phenomenon.
Exactly.
Okay.
There's actually some science behind it. I didn't just
Gotcha.
take a flashlight and
So according to published research, you can use infrared light in order to measure bone density.
Yes, you can.
And that's what you have devised here as an instrument for measuring bone density. Doesn't that already exist?
It does, but what the problem we're trying to tackle is the fact that the machines that are currently doing it are costly and they're large. And for some segments or some markets, that might not necessarily be a good thing. So, for example, if you have a rural community in Eastern Asia, for example, that might see a doctor once a year, and there's a ton of elderly people, osteoporosis being a big deal, it's very costly. I think in France, just to give you a figure, I think it costs the country more money than heart disease or cancer. It was cancer. Cancer, yeah. And it's also I think expected that 1/2 of all women over 50 will experience some sort of injury that's a direct result of being in an osteopathic state, osteopathic poor state. So.
Okay. Brian?
Now, was this modeled as a preliminary measurement device?
Yes, yeah.
So let's say I am reading out really terrible bone density. I would have to go and get read from some big expensive machine to confirm that, right?
Not necessarily. I can tell you that in terms of accuracy, the research, the science has told us that it correlates with the wavelengths that I'm using right now of light, correlates 95.5% to bone density. So it's fairly accurate. It's not 100%. Like it's not a DEXA scanner, which you're probably referring to. That's very accurate. We don't have the ability to target certain areas of the body yet. I haven't really tried anything besides the wrist or the finger. So that's another thing. You can have a bone mineral density poor region of your body that might be localized. So for example, a hip or something might have less bone density than say like a wrist in some people. It all depends, but it'll give you a good general portrait of your bone health.
Does your device have any sustainable competitive advantage over the other devices?
I would say so. It is cheaper. I mean, it is significantly cheaper. To give you some figures, the closest machine that we could find, my team could find used, was a sonogram type machine that you would use ultrasound to basically detect the deficiencies in bone density. So, and I think that was $5,000 used. Ours, I built that with less than $400
Well,
myself.
can't anybody come along and build one cheaper? That's what would make it sustainable. If you could prevent me from doing it because of your patent.
Okay.
Is this patentable?
Okay. I would say so. I mean, there already exists a patent. That's where a lot of our research was based off of, but we think we're distinct enough, or we're building on the studies of that. Furthermore,
Are you infringing on somebody else's patent? Do you have the freedom to operate?
Well, we think that we're distinguishable enough. We're using similar technology, but in a different way. I could get into the details. We're also adding a lot more to it. Our idea is not just bone density, but also elements that also use infrared light or other light, such as pulse oximetry, blood flow, that kind of thing, through the skin, not only the bone, so you could get a really good portrait of your total health. We're working on that.
So are there other patents in force right now that you think you might be infringing on?
Perhaps.
Aha.
I'll give you that. It would be up for debate. There, the legal stuff is still murky, as to how it
You
would.
know you can be an infringer of a patent without getting actual notice. Actual notice could make you liable for triple damages, but without actual notice you could develop your entire product and start to market it and still be infringing on somebody else's patent. And when they discover your product after it becomes successful, they could then proceed to give you actual notice. In legal terms, actual notice has not been clearly defined. You don't actually have to be served. They could just send you some sort of a letter. But that might be sufficient for actual notice, a certified letter that says cease and desist. In which case, their monopoly on this intellectual property could require substantial legal fees on your part in order to try and challenge the actual notice.
I mean, a good alternative to that would probably be licensing, getting like actual permission.
Have you attempted to license the technology from anyone?
We're just in the development stage.
Ah.
We haven't actually.
Have you approached the technology transfer officer, Ben Muskin?
Yes, we have. And
so you aren't just in the development stage.
To me, we're in the development stage.
It sounds like you're trying to represent it as something that might have value.
Indeed.
Commercial value.
I think it does.
So then the questions of intellectual property somehow seem relevant.
They do.
Well, I don't wish to be a gloomy Gus. Does anybody else have any questions?
You come up and try it out.
Ooh, okay. Can I measure my density?
I'll give you one reading. Take your pick. 1050, 1550, or actually I could probably do both, but I don't have enough hands.
I don't know what you mean.
Well, if you put your finger right there on top of it.
Over here?
Like
right. Ow! I got a shock. I was going to ask you that.
right there.
Okay.
Cool. So you can. Just gonna pull up a serial monitor.
I'm going to sue. Your device shocked me.
That'll never hold up.
I've been traumatized.
So welcome to
There's only batteries here.
3 volts of that. So
right now.
No, I think it was more than 3 volts. It was spark was an inch and a half.
Yeah, we need to get that product liability insurance.
So gonna turn it on. This is gonna measure the 1550. So the second number.
Is it measuring my density of my fingernail?
Huh? It's measuring the. It's measuring the density
I'm liking
between
your packaging.
Well, thank you.
Did you do a product design for this?
Extensive PR.
What's
and
that?
marketing and stuff. This is a.
That's an LED.
Far
What's
infrared LED. This is a near infrared LED.
Oh, so do you use both?
You can, yeah, and these two would actually give you a bone density measurement, provided I put the two measurements in a ratio of logarithms.
Oh,
so
fancy.
Yeah, not too bad. So I'll actually do both of them now.
Okay, I'm ready.
Okay,
This is all battery operated?
All battery operated.
Oh boy, and how much power does it take?
3 volts.
Well, no.
Oh.
What's that voltage? Are you an electrical engineer?
So there you go. You got a number here, a number here. These two you would put in a ratio. So it would be one over the other, and you could get a number out of that. And
So is he gonna be okay?
I think he's gonna live. I think he's gonna live.
So tell me again how much power it uses, and don't say 3 volts.
Let's see. So it'd be, I think it's 0.3 watts, if that.
Oh, all right. So that's not bad.
100 milliamps max, I would say, probably.
Okay, great.
And then,
You've got like two. What is that? A coin cell over there?
That's a coin cell.
Oh, I see. So you're not using any supercapacitors at all?
Nope.
Wow, I wasn't aware you could do electronic devices without supercapacitors. Would someone else like to try this?
Did it work? It worked.
I guess.
Got
I got numbers. Numbers came out.
We don't know exactly what those numbers mean, but we can correlate them if we got a.
So how much will you sell this for?
Depends which market.
Depends on which market.
Kickstarter.
He's my business guy.
Sell it on Kickstarter to the Arduino crowds. Call it the Bone Density Shield.
Bone Density Shield.
And by the way, you should charge twice as much as it costs.
We're thinking 400%. What was it?
Yeah, we were looking at actually higher.
Because it's so cheap. I mean, Like it's it's not really that much to produce.
And
We're actually considering marketing it towards actually the general family practitioners so that they could generate a new revenue stream for themselves.
Well, I'll definitely buy one. But if I was Kevin O'Leary and I knew that you hadn't done a proper vetting of the patents that pended on this, then I would say, you're murdering money. Because you're not far enough along. But I'm not him, so I wouldn't say that. And this isn't Shark Tank. It's just a classroom.
This is just Fairfield.
So I'm thinking that when Johnson & Johnson finds out there's a big market for this, they'll crush you like the cockroaches you are.
Jeez. Yeah, numbers.
So you need to, I think, lock down your intellectual property. Now, how much of this is owned by you and how much is owned by Fairfield?
I don't know.
Ooh, good question.
Well, if you go to Fairfield and they sponsor the patent, don't they take
Half.
the entire patent?
They take half.
Well, have you read the intellectual property agreement for faculty?
Wouldn't they get? I think they get half.
The entire assignment goes to the university.
So how do
You can be an inventor, but you don't get the assignment. Then they pay you a royalty. The university has a rapacious appetite for these things. Have you looked at the draft student intellectual property agreement?
No.
I actually requested to see that a couple weeks ago, but...
And you didn't get it, did you? Because it hasn't been approved. I only have a draft.
So that won't hold up.
So then it doesn't hold up in court. It hasn't been established yet.
Well, are you aware of the case history in this matter?
It always.
At University of Mississippi, they found some student was actually making money from their dorm room and said, "Oh, you used our resources, therefore we own it."
Was he
I live off campus.
Was he Bitcoin mining?
If you're are you using your resource? I mean, who bought all that stuff you're holding there?
My NASA grant and myself personally.
And was that NASA grant assigned through the university
Through
office?
the university.
So
they own probably
university
40% of this if you were going to be.
Tell it to the judge.
Now,
So
I actually have a question from that perspective. So how do you motivate people to innovate or create products? Because then I'd wait to leave college for that.
I think that's very wise.
Could do that.
But then why for it? But at that point, it's like...
If you use extensive amounts of university resources, if you approach Ben Muskin, if you use university general counsel and patent attorneys, you're basically giving away equity. So that's a compelling argument for paying for your own stuff as you go. So if you want a business plan competition, as my team has done, and then use your own money for this, as my team has done, and then if I proceed to, let's say, subsidize some part of it, as I have done, then maybe we can separate ourselves from the university. This has not been tested yet. If the university turns around and says, no, it's all subject to our purview, then we have issues with the intellectual property agreement that I'm subject to. So I often take my medical device development off campus and get it as far away from the university as possible, because I don't want to give away equity.
Yeah, absolutely.
And if you go to Kickstarter, you don't give away equity. So you guys weren't at the Kickstarter presentation last month.
So if I went to Kickstarter, I wouldn't give away any equity at all.
None.
How would you give it?
It's still selling. My thing is still selling.
Significant investment, though. So
Well, how much does it
just the
cost?
FDA regulatory approval is estimated to cost around $250K. So.
That's not out of the question for most angel investors.
True.
If it was me, I would pay it if I thought there was a market. In fact, if you're doing a medical device, I'm not even sure you're allowed to do Kickstarter, but Kickstarter has done pulse oximeters, and I bought one, and it interfaces to the Arduino. So as long as you're doing something for a hobbyist, you can see if there's any demand for it.
There's definitely
of people bought the pulse oximeter. They love the biomedical sensors for the Arduino crap. And Arduinos typically raise 3 times more than they ask for when they go out into Kickstarter, which is way better than, let's say, the iPod accessories.
This little guy.
Yeah, that guy raised $320,000 with Velaz.
Seriously.
Yeah, that's OpenRF.
Yeah, and it's a great product. I mean,
I have actually another quick question.
And that's his second Kickstarter project. I backed his first one as well, OpenRF. Yeah.
Would the university have, could there be potential options for you to purchase the equity? Like have an option to be able to purchase
It's all up to
equity
them.
out? I mean,
I don't recall anyone ever having done that.
Well, it depends what your contract says. When you sign on as an employee.
Oh,
you
well,
can
they're not
negotiate
employees, they're
before-
students.
Well, yeah, but I imagine every senior project has a faculty advisor.
Mentor.
Yeah. So
We
it
do.
depends on what it says in that faculty advisor's contract.
Yeah.
They're going to be publishing of their research and their papers. The professor going to publish something from it. Like things like that. It gets complicated.
Yeah, besides, what you have there needs to be productized.
Yeah, this is just.
It's a breadboard. It's a pre-prototype.
Yeah. You can't even. I mean, you couldn't even claim intellectual property to a breadboard, could you?
Yes, you could. Absolutely. If you had some innovation, some algorithm, some invention, and you were the inventor, you could definitely do that. So there may be some algorithm involved in doing bone density measurement that you've devised on your own, and you could document that algorithm in your lab notebook, prove priority, and assert the intellectual property for that algorithm. And then you could license it to others.
Would documented code count? Like dated code?
You could certainly use code, but you can't use electronic records on the computer like your documented code to prove priority, as far as I know. Normally you use a lab notebook.
Okay.
Normally. But you could try it. I mean, there may be case law available for that. I don't know. We do teach patent law here on campus. So there's a patent attorney who teaches it, Mike Blake.
Is that part of the ECE grant
It's in
program?
the MOT program.
Ooh, okay. So that's touchable.
Absolutely. You could take it as an elective.
Done. So that would be good.
name again?
Mike Blake. He lives in Milford, but his bachelor's is not electrical engineering, it's mechanical engineering. But he can still be used as a source of information about patent law,
Bless you.
which is gesundheit, changing all the time, unfortunately.
Yeah, this little messed up.
Yeah, they got it. Well, aside from the America Invents Act,
Yeah, that
there's a
was
new
really
thing
messed
being
up.
put out that is being discussed that has to do with patent trolls.
Oh,
Yeah,
good.
that's ridiculous.
Get 'em outta
You
here.
could see them buying the patent from the university in Japan.
Off topic,
trying to beat
do you
us.
have IntelliJ
Get money out of
license?
I do have an IntelliJ license.
A key?
I have a key.
Oh.
We ought to.
Could you send me that my way when you get a chance?
Yes, I could.
Thank you.
It's also in the video.
It's in the video?
Yeah. Not Java. You have it for like loading up IntelliJ.
Oh, yes. Yes, there's a video on how to run IntelliJ and get the license.
Oh, okay, thank you.
So I think that's very nice. Thank you for the presentation.
No problem.
When I ask probing and difficult questions, it's because I'm playing the devil's advocate, and my goal is not to be a hard tush, but instead to prepare you for the hard questions. So if you haven't done a proper patent search and you know you're infringing on someone else's property, it's really good to come up front and say, we have an opportunity here to license the existing intellectual property and then do an improvement patent. And our improvement patent will claim XYZ and is licensable to others, or we could proceed to manufacture on our own. And so your strategy on this to license from someone else is perfectly fine and legitimate. And in fact, the strategy to get a patent is what I would call a business decision. And you have to value your patent based on the claims that it contains. So the question of exactly how you value a patent is kind of an art, but it may give you a sustainable competitive advantage. Right now, what you have is something that could be easily duplicated. You probably took no more than, I'll say, 100 hours, and anyone with reasonable resources could have duplicated that in 100 hours.
Agreed.
You know,
Agreed.
I could probably hire a consultant, and not only after 100 hours of expenditure would they have a prototype, but it would be on a printed circuit board that fits into a nice case that we could 3D print.
We're about at that stage too.
So, I mean, you know, if you've seen my circuit boards, they're perhaps somewhat less complicated than what you have, but not that much.
Yeah.
Really. So, good. I'm glad you guys are working on it. I'm really enjoying the entrepreneurship coming out of the School of Engineering. We haven't seen that come about before. And I like to think I had a small role in it by starting a little Kickstarter project and getting people inspired. Right now, the way I see it, what you guys are doing is entrepreneurship with training wheels. You're learning, and that's the most important thing, and that's why you're here. So if you treat it as a learning experience, it's fine. If you want to just get a widget out the door and start selling and see what it's like to bring a product to market, you'll learn a lot, and you'll learn it fast. And in fact, if you go to freelancer.com and take your schematic and just send it out, someone will happily convert it into an Eagles schematic and printed circuit board for under a couple $100. And then you can go out and I think we just did a spin. $34. $28. And when is this due? April 9? Next week. So total time for 2 weeks to make a printed circuit board. So if you guys want a circuit board, you have to do it now. You don't have any time to wait because 2 weeks from now, you're still going to want to populate it and test it and maybe do another spin. And that'll be something you can show people and say, look, it's a product. Bob Oro's speaker chair of the Inventors Association of Connecticut says, you have to show the monkey the banana. So what that means is you have to have like a real product that people can see and point at and look at and say, look, these people are serious. And they invest in people, not products. So they'll see you as a team that's actually serious in doing your development.
Nice.
So and also it's not know-how, it's know-who. So start networking with the angels, come to IACT meetings, go to the CBG meetings and the CTC meetings, find the investors and the people who are business people looking for the next big idea, and bring your big idea with you. You can go to the New Haven Grid with this stuff. There's an ecosystem for entrepreneurship here in Connecticut. Don't do this stuff in isolation. It's a big mistake. So I say if you meet the right people, you won't need a business plan because they'll just look at your device and they'll say, this is great, let's invest in it. Yeah. Much more compelling than a business plan. Business plan competitions are competitions for writing business plans. They're not competitions for making products. That's what engineering school is for. I'd much rather have a product than a business plan. And in fact, if you look at my Kickstarter, not only do I have a product, I have profit and sales and customers and no business plan. My plan is to grow the business. That's my plan. All of the demographic projections you do when you try and do marketing are pure fiction. If you don't actually have sales from individuals and money, then there's really no way you can do this kind of planning. And you cannot estimate the value of a business based on the idea that somebody has or the patent that they hold. Ideas are worthless. Inventors hate it when I tell them that. Ideas are worthless. They think their ideas are the best thing since sliced bread. Let me tell you something. If you don't have execution, if you can't manufacture, if you can't sell and market, you got nothing. You're 90% of the way there, you haven't gotten over the hump, and your business will fail. So it's much better if you can bring a product to market and show sales and profits, and then your valuation is viewed completely differently. Now you have traditional metrics evaluation. You have profits, you have a rate of growth, you have revenues, you have customers, and it shows that you can execute. It takes away the execution risk for the investor. So that's my little speech. And by the way, bringing something to market and waiting for the FDA to approve it, I think you would have to make a compelling argument that this is a PMA. It's a preliminary medical device, as a pre-existing medical device, like a Band-Aid.
Yeah.
So if you had a Band-Aid and I say, oh, here's a new Band-Aid. First of all, it's a medical device. Now it's subject to a medical device tax. Great, we're taxing Band-Aids. And now you can say, because it's a pre-existing medical device, look, it's just another kind of Band-Aid. It's the ouchless Band-Aid. And so whatever that means. It turns out you got already approved medical devices out there. And they do exactly what you're doing now. So I see no reason why the FDA wouldn't hold that up. And there's a compelling argument that it should go quick.
Right. It's very low. It's non-invasive. There's no.
And it's a non-invasive medical device.
And it's not even like dangerous light. I mean, you give off IR light.
X-rays. Ooh, it's radiation.
IR light?
IR. Well, sure, it's radiation.
Yeah, but I mean, like. I'm getting
see
it.
the light in this room?
Yeah, but it's,
That's radiation.
but it's
Oh, yeah, of
technically
course.
categorized under level 3, so it's probably like it's not the.
If you take the light in this room and you focus it into a little 1 millimeter space and shine it into your eye, it'll blind you. So what you have here is diffuse radiation. But if you take the radiation and you focus it, then it becomes very dangerous radiation. And what you have is radiation that goes through a focusing lens. And it's invisible to your eye. And it can shine into your eye. And so the question of whether that can do damage or not is still open. A lot of people use IR to do eye tracking, but they do an eye safe level. So I don't know what level that is. Hopefully it's eye safe, but you have to make it safe. And this is one of those compelling arguments. You know, the fact that it's invisible makes it more dangerous. I have a CO2 laser in the next room that cuts through plastic.
You got a CO2 light?
Yeah. This here, this is what a 90-watt laser does. It's invisible light, right? It's IR, same frequency as you. It goes right. This is a CD case, 90-watt laser. Goes right through it.
Do we have any other lasers?
Yes.
Like a Q-switch lag, YAG, or any of those?
Yes, we have a YAG laser in the basement of McCullough.
Kidding?
So no,
Hanging out in the basement.
it's in the basement. So I mean, this was the CD case,
Yeah.
and it's IR light. So don't say IR light. Oh, that's not dangerous because it's non-ionizing radiation. Dangerous.
I can tell you how much it puts out. It puts out like a tenth of a watt.
Well, I don't know what's eye safe. The
That's not
FDA will tell you that.
But you're going to be focusing in also on people's backs and hips and things like that.
I just did that today.
Yeah. I mean,
But you're going to need a bigger sensor, right?
no. That's it.
That's
That's it. Yeah. That's the only. That's the beauty of this device. It's that small.
Plus, normally just the wrist is a good indicator for most of the other parts of the body.
And engineers have a nasty habit of racing to the bottom, saying we're going to build it because it's cheaper, therefore people will want it. But what you really want is a small market where you can charge a lot.
That's what we're trying.
And so it's much better if you can charge a lot for something than if you have to sell a whole bunch of something and charge a little. Then you get all involved with fulfillment, and it takes forever to ship things to different places, and then you have returns, and you have to deal with customer service. It's a big deal. And software, and updates. It's a big deal. All right, guys. Thank you.
You're welcome.
So, hey, how about that midterm?
Oh, that's what.
Sorry, guys.
We were trying to do something with median cut algorithm, which is color requantization. Right? Oh, thank you. Did you pass this around? Anybody else want to see this? All right. Yeah. This is my. This is what Someone wants to say, infrared, that's not dangerous. That was a CD case. I have lots of extra CD cases, and I decided I would use them with my little infrared laser system. Yeah, lots of fun. We're recycling. It's very green. It's also very smelly. It probably emits greenhouse gases, too. So I'm thinking that some people were a little bit confused by the idea about the lookup table. And they said, I don't know how to make a lookup table. And so then I said, well, that's interesting. We had a whole chapter on this, and it was called Chapter 4, Homogeneous Point Processing. And in homogeneous point processing, we showed you how to do transform tables. And so here's a transform table, which I had distributed with my code, called the HPP transform table, which stands for homogeneous point processing. And someone real quick tell me, why is it called homogeneous point processing? Yeah, it treats them all the same. So what you get is if you look at it here, 3 different arrays of 256 shorts. And those 3 arrays are used to take values on input and give you values on output. They are effectively nothing more than 3 different functions, where the function of x returns y. So it's y equals f of x. That's what this is, only for red, green, and blue. And the arguments for x are limited, because x, first of all, if it's a pixel that's in the integer space, it's only a number that goes from 0 to 256 when you're dealing with an 8-bit quantity. So I create a function. This is the homogeneous point processor filter interface, which, by the way, if you look at it, is a trivial interface that defines 3 different functions. And what does it do? It digitizes those functions. It runs the functions and then proceeds to instantiate your little transform table. So here's the transform table being instantiated, and then if you want to, you can apply the lookup table to an array of red, green, and blue. And this is how you use the lookup table. You basically take the red, green, and blue value and replace it by passing it through the lookup table. And that's, a print statement. And that's it. Where is it? The lookup table is right here. What do you mean, what am I doing with it?
I don't understand what it's doing.
What it's doing is it's taking a 2-dimensional array of red, green, and blue, and then it runs through every single pixel in the 2-dimensional array, and it maps it from one value to another value. By using this lookup table. It takes the value, runs it into the lookup table, and gives me a new value.
Do you understand what I'm asking?
No.
I don't understand how it does that. I understand that, I know that, and I know, but I don't understand how it does.
Okay, let's assume that I create my own little lookup table. Here are the values: 1, 2, 3. Whoops, I'm doing this wrong. 1. Let's start with 0. Let's make a lookup table. 0, 1, 2, 3. Okay. Now, if you see a 0, right, we can map it to a different value. So let's give the new value for 0, 4. And here's one called 3. Actually, we could do it this way. 3, 2, 1, 0. Okay. So now I've created a lookup table that says if you have a value called 0, it will map to a 3. If you have a value called 1, it'll map to a 2. If you have a value called 2, it maps to a 1. And if you have a value called 3, it maps to a 0. Well, we call that the inverse lookup table. And that's defined in Chapter 4. So what this is doing is it's saying by creating I'll call it a function that has been digitized into an array, we can use the index of the array as the independent variable, and the contents of the ray as the dependent variable. So when you try to do something like y equals f of x, like this, y equals f of x, right, we're identifying x as the independent variable, and we're defining y as the dependent variable. So then when we digitize a function by saying, well, let's let f of x equal, we'll say, I don't know, 3 minus x. Okay? So if f of x is equal to 3 minus x, then what I can do is I can say, aha, this is equal to 3 minus x, that's the function, where x is equal to the value over in here, which I will call the independent variable. And now if I take this and I stretch it so that it goes down across the column, I've digitized y equals f of x, where y equals f of x is equal to 3 minus x, and I've implemented my inverse operation. So now all I need to do is build an array where location 0 contains the value y equal f of 0, and location 1 contains the value y equal f of 1. And so now when image pixel values come in, I need only pass them into the array index, and then the value will pop out. So while this may be a trivial computation for the function, I could use arbitrarily complex functions, then digitize them, and treat them simply as a table lookup. And so this enables me to greatly speed the rate at which I can do my image processing when I'm doing the homogeneous point processing. So I could, in theory, create a pseudo-color algorithm, as I have done, that uses sines and cosines, complex trigonometric functions, and then just digitize those functions using my lookup table and greatly speed them, make them as fast as any memory access.
In this HPP transform table, can you show me like where you're implementing function? That's what I don't understand. I get like the concept of what a lookup table is, but I don't get how to apply a function to it to make it do a certain thing.
Well, sure. If you look at the no-op filter, what we've done here is we've implemented the HPP filter interface. And what that does is it returns the no-op application for this value. And that no-op application basically says, look, you got a value coming in, it checks the range, and otherwise it just returns the value.
So what does that do? That just converts it?
Yeah, this is providing you with the function which can then be digitized into a lookup table. So if you want to find usages of the no-op filter, I think it should be in here somewhere. Well, we could probably devise a no-op filter implementation if we like. You can also find it in image utils. Right, so here's the homogeneous point process interface, the filter interface, and what it's doing here is it's getting an RGB image filter, and then it's applying the filter. So if you look at the RGB image filter, it's just going and getting you the 3 different functions, red, green, and blue, and then to get the image off of that, you can see the functions coming in, and it says new filtered image source. So you're asking me the details of how you apply it. And here's an image filter coming in and then being used. Let's see if this is filtered image source. This is getting into too much detail on the abstract window toolkit.
I'm asking, can you go back to the HPP transform table? Like, I don't understand how what you have there is functioning. Like you're skipping over that middle part, the transform table part. Like what does that do? So I understand that you want the array that is the lookup table,
Mm-hmm.
and then you have the for loop that
Yeah, this
why?
instantiates the lookup table. You have to populate the lookup table.
So what are you populating it with?
I have to pass in some sort of implementation of this HPP filter interface. So I need a set of functions to be defined by somebody who will effectively give me a way in which to modify the pixels. This is what you might call inversion of control as a design pattern, because I'm requiring, you might even call it polymorphism. I'm requiring somebody provide me with a set of 3 functions, one for red, green, and blue, and then I will use those functions to digitize. I will digitize those functions and populate my lookup table with those functions. So if you want to see somebody who let's see, implements, you can see it's implemented in 10 different places, and yeah, okay, so here's a pseudo color filter. That's a nice example. So the pseudo color filter defines interesting looking functions. These functions need apparently some parameters, and I really hate the fact that IntelliJ has somehow decided to reformat all my code for me. I honestly do not understand why it's doing this. So here's this. Here are these interesting and wonderful functions, which apparently take 3 different parameters and values, and they then map red values to new values, and green values to new values, and blue values to new values. All right? So that's, so far so good. My pseudo color filter basically modifies an image to make it colorful. Does that make sense? What are the new values? I don't know. The new values are going to be computed based on this function. And the function says, take the sign of whatever and do some stuff to it. That's kind of not relevant. But, I mean, you know, if you want, we can get a simpler function. What is your question?
I don't know. I don't understand. I keep trying to ask it, but I'm not. Apparently, I'm not.
Could you go back to the code, the HTTP filter?
Interface?
Yeah, before that, where you implemented it in your median cut algorithm.
In the transform table.
Okay.
I haven't talked about the median cut algorithm.
You're talking about
This is pseudo color.
transform table?
Yes.
The HPP transform table.
Right here. Okay. F dot get R provide. What does that do?
I have been HPP filter interface implementors are containers of 3 different functions, and these functions input a value and output a value. And so I have to rely upon someone to provide an implementation for those functions, because I really don't know how they'll be implemented. But what I do know is, if you have implemented them, then you have provided me with an implementation of an HPP filter interface. So when you look at the HPP filter interface and you find the usages, you look for implements, and then you see, aha, here's an implementer called invert filter. That's probably a better example because it's the simplest example I could think of. So now invert filter says, I will treat red, green, and blue the same, and I will treat them by taking the value and subtracting it from 255. How's that? Good, right? Now the image processor interface, if you look at that, requires that you implement the process image, right? So that says an image comes in and an image comes out. That's the simplest possible interface I can come up with an image processing operator. It's basically a goes into and a goes out of. So I need to know how to get an image instance from, let's say, a file, and then provide an implementation for the processor, whatever it does to the image, then take the image that comes out and then display the image. So if you look at like this invert filter over in here, it already provides you with a processor. And in fact, it uses the homogeneous filter image processor, which allows me to input one of these implementations. Here's a main. Doesn't look like it does much. But what I can do is I can get my processor from my invert filter. And say new invert filter. And now I can go to the invert filter and I can do a get processor. In fact, I can do invert filter.getProcessor. Since it's static, I can just call get processor. And so here's my new image processor interface implementation. I'll call it implement interface can't type it. Equals. There. So now I've got an image processor interface. I can go get an image. And then I can, what do I need, a semicolon? So he's unhappy because I have to import the class. So getImage requires a file argument. That will give me an image instance. Then I'll call the image processor interface implementation. Let's give it a better name. How about this? Processor. That's better. So now what we'll do is we'll take image, img, and set it equal to processor dot process image. So that will allow me to overwrite the image. And now what we'll do here is we'll say something like image utils dot display image. And this is the inverted image. And probably we want to do the same thing prior to the inversion, just so that you can see what it's like both before and after. Oh, I gave it the wrong title. That's all right. And there it is, before and after. So a homogeneous point process can work as fast as any lookup table.
So that wasn't on.
Did we use the lookup table here? I used the invert filter, and I passed it into the homogeneous process filter image processor, whatever that is. And yeah, it's using a lookup table. It populated the lookup table and then did a lookup, and I don't know.
Can you show how to do this manually?
Manually?
Like, I want to know how to do it. Like, I don't understand. Like, you're just like, without the interfaces and the methods and everything are confusing the actual concept of generating a lookup table.
Okay.
I don't know if that's.
I'm under the concept of a lookup table.
I understand the concept of a lookup table. I don't understand how to apply it. Like, I don't know.
Well, I have other implementations if that's of any use. There's also well, let's try this. Here's the knee. Now we'll do escape n. So that's doing a negate filter, and if you try and find it, there's negate, and there's escape n. So that does the same thing. You can see the keyboard shortcut involved escape N. So if you go into the filter frame and look at the negate menu, you can see where it's implemented. And so apparently it's implemented in the short image bean, and now it's using the inverse filter and then doing a process. So now here we have, is it a lookup? It's using the homogeneous point process filter directly. So I'm not seeing a lookup table here, although it wouldn't be that hard to implement one. It would mean, let's see, how does this invert filter work? Yeah, it's just directly calling the interface implementation. So if you look at it that way, it's not using a lookup table. We could re-implement it so that it does. But when you're just subtracting... Oh, thank you. You're off to another class? Thank you. So if you're just subtracting, you kind of don't need a lookup table. And it might even slow you down to create one, now that I think about it. But it's not that difficult. So I'm trying to get my hand around the issue that you're raising that makes this hard for you to understand. Can you ask your question differently?
I don't know. I feel like I'm wasting everybody's time. If everybody else gets it, I don't
Well,
know.
I don't know that everyone else gets it. Yes, Rich?
We're going to say a lookup table is just an array, right? Where the
Yeah.
index is the lookup value of your input, and the value stored in that is actually 0.
Yeah, so how do I know what to like store
Okay, let's do an example in the
in
arrays.
that lookup table?
Depends on your application.
Depends on what you're wanting to
So
try.
like, okay, so can somebody show me, for example, a correct solution to the midterm? Because I do not understand how to do that. My
Well,
output was wrong. That's because I didn't understand how to implement it.
wait a minute. Are you asking for a correct solution to the midterm, or are you asking for an illustration of how to do a lookup table?
Kind of both. Like,
Well, I'll show you the lookup table right now.
yeah, please.
So LUT example. Okay? So let's do a lookup table that allows us to quickly implement a function. So what we'll do is we'll create an array of 256 elements. I guess that's an okay thing to do, right? Integer LUT array equals new integer of 256. Okay so far?
Yep.
So now what I'll do is I will create some sort of an instantiation of the lookup table, and I will do that as part of the constructor. And I'll write a for loop while I is less than LUT.length I++, and I will create a invert lookup table. And so what it'll do is it'll make LUT of I equal to 256 minus I. So when I is equal to 0, this will be 256. Maybe it should be 255 minus I. And when I is equal to 255, it'll be equal to 0. So far, so good, right? So now what we'll do is we'll apply the lookup table in a main method, and we'll make a new instance of the LUT example. And then what we'll do is we'll say L dot lookup table of, pick a number. 7. Okay, so that should be 7 minus 255. And so now what we're going to get is an integer equal to that value. And then what we'll do is we'll print the value. And then we'll compare it with 255 minus 7. And he doesn't like it, but he's okay now. So let's see if that works. Yep, same value. So effectively what we've done is we've sped up the computation. Well, I don't know if we sped it up, but we duplicated the result of the computation of 255 minus 7 by instantiating a lookup table and then using the index into the lookup table as a, how would you call it, a way in which to implement the function. Right? That mapping that the function gave us is a mapping which we can directly impose. So if in here you wanted to go and get an image, right? So here we'll do feudal dot get read file, and we'll just input an image. Okay. Now he's giving me a hard time. Oh, this is a file. What's his problem? Oh. Alright, so now I should be able to get an image, finally. And so now what do I do? You tell me.
You have to treat the folder where mapping the index.
But I've got an image data type here.
Oh, you have to convert. You have to get, I guess, pixels.
I have to get the pixels. Oh, how do I do that?
You use get pels or get pixel.
I can use getPels, like img.getPels. Oh, ImageUtils. Oh, ImageUtils dot get pels. It comes back into an array, img. So now I've got these pels, which is an array, and it's an integer. Now what? Got to go through each pel and do a mapping, right? For integer I equals 0, while I is less than pels.length I++. Now the pels are packed pixels, right? That's red, green, and blue. Suppose I just wanted to deal with the least significant 8 bits. How would I grab that for each one of the pels? That would be the blue bit. Integer b equals pels of I and with 0xff. And that's the wrong kind of and. I need a bitwise and, not the logical and. So now I've got the blue plane. Now I want to apply my lookup table. B equals B of LUT of No. B equals LUT of B. I got it backwards. That's normal for me. Where's the LUT? Oh, this is static, huh? I have to go into the instance of the LUT. L dot LUT. So then what?
You're gonna set the pels to the lookup table at an index.
Okay, so now I go to pels. I go back to the pels of I, and I set it equal to no, that lookup table is only going to give me one value for the color, but the pels has a packed pixel in it. So I have to take pels of I and replace the least significant bit. Right? I didn't get. I only did blue. How would I do green and red? Red, green, and blue. Right? I have to do all three colors, right? Or do I want to just make blue the same color for all of them? I could do that. 0, X, FF, shift it over by what? 24 bits? I could do it a different way. 0, 0, 0, 0, 0, 0. There. How's that? And then I can AND it with, OR it with, inclusive OR it with B, inclusive OR it with B, shift it over. See, if it's FF, it makes more sense to use the shifting. Shift, shift, 24. B is shift, shift. Now I want the red, so it's not going to be 24. It's going to be, what, 18? And then you're going to have B for the least significant bit. Shift it over. I guess it would be 16. Did I get that wrong? I guess this would be 16. This would be 8. And then just put the B in there for the least significant bit. Because I got to have the alpha. Then I have to have red, green, and blue. What's his problem now? Oh, yes. Oops. There. I don't normally write code like this, but there it is. So now what do I do? Well, I already did the mapping in blue, and I decided that we would use the same value for red, green, and blue, since it's a grayscale image. So we're just going to make an assumption that the blue is the only thing we care about, and then I got to convert this now back into an image. Can I get the image from pels? No. There has to be another getter in there. Because I need a 16-bit image, right? Pels image, is it? Oh, pels to image. And what is the width and height? Did we get that? Oh, and this becomes a new image, right? Image img2 equals, how's that? And so now I can do image utils.display image, put in the image, image 2, and inverted, and that's it. What do you think? Shall we do the before and after? We'll do another image utils display over in here. Whew! It's a marathon of bit flipping. And now we'll run it. And what does that buy me? Array out of bounds exception at runtime. I'm just guessing. I don't know. Oh, look, it worked. How about that? Lookup tables in action. That could be my next Manning Press book. Lookup tables in action. What do you think of that? That all right? Does everybody understand what I did over in here? Do I understand what I did over there? Let me write some comments. Pels are packed pixels. So they're going to be in the format alpha, red, green, and blue. So what I did was I made alpha the overlay plane FF, which meant it was clear. And I shoved it all the way over so it's the most significant 8 bits. Then for the green and blue, I just copied blue into all 3 colors. The lookup table computation was done all with let's say with a trivial function that had populated it in advance. I could have used a different function. Suppose I wanted to do something different for each color, red, green, and blue. What would I have done? How would you extract green, for example? Let's make this green. How would I get the green component? Yeah, that's going to be this is where the green component would normally go. This is where the red component would normally go. So how will I extract the red component from the pixels? Each pixel is a 32-bit quantity, right? The least significant 8 bits is blue, right? The next 8 bits is green, and then the next 8 bits is red. So I need to be able to extract the green. How do I do that? Yeah, I gotta shift it. So shift it over by 8 bits, and then mask it with 0xFF.
So what does the masking with 0xFF?
What that does is it takes the least significant 8 bits. That's an AND, a bitwise AND.
Yeah, so we're ending it with 0xFF is
That's 255. 1111 1111 in hexadecimal.
okay.
Well, in binary, but it's a hexadecimal number. And so now if I want red, what do I do? Well, if I shift to the left by 16 bits in order to impose the red into the packed 32-bit quantity, what do I do in order to extract it? Brian? No clue, really? Rich?
Do the same thing, but 16 bit.
Yeah. Just shift it over to the right by 16 bits. So if you have to shift it over to the left by 16 bits in order to get red in the right place, then you shift it over to the right by 16 bits to do an extraction. Now suppose I wanted 3 lookup tables. Right? So I can do that. I'll make lookup table 1, 2, and 3. But I'll define them as red, green, and blue. And then what I'll do is I'll populate them with red, copy, paste, 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 green, and blue. And I'll use lookup table red, and now I'll populate all 3 with the inversion formula that I've got, my trivial inversion formula. And I can use the same example in here. Now only here I'll use blue, copy, paste, 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 and this will be red, green, and blue, and this will be red, green, and blue, and we'll make lookup table red, and lookup table green, and lookup table blue. So now what's going to happen? I've got 3 lookup tables all populated with the same function. Presumably, we'll be able to come back and get an inverted image, just like we did before. All right? Fair enough. So now I can use an arbitrary function for red, green, and blue. And someone said, oh, I've got a pseudo-color filter. And the pseudo-color filter can be used for my arbitrary function. And it even takes a null argument. So I can make a new instance of pseudo-color filter. I can then proceed to where was I? Here. Found it. Sorry. So now I want to populate my lookup table. So what we'll do is we'll populate the lookup table with a filter. We'll get a pseudo-color filter, PCF, equal to a new pseudo-color filter. And then what we'll do is we'll populate red, green, and blue with PCF.getRed, and we'll put that in with I. And then we'll do the same thing for green and blue, only we'll use the function green, and then we'll use the function blue. And so now I've used my pseudo-color filter to populate my lookup table in order to alter the values that have been packed into the pels that were extracted from the image. And presumably this will do something. Maybe. And maybe it will run while we're young. Oh, there it is. So here's the knee, and here's your knee on pseudo-color. Ooh. Ah.
So that get R and get G, it just changes the red, blue, and green to some
Yes.
pseudo different color.
Yep. And they operate independently from one another because there are 3 different lookup tables. And so lookup table population has been determined by some relatively strong parameters. When you make a new instance of a pseudo-color filter, you have an opportunity to change those parameters. For example, 0.5, 0.3, 0.2 should give you different colors. That's what I mean by strong variables. because those little variables in there should give us radically different behavior in terms of the coloring that we get from this knee image. And certainly that's true. So if you look, if you create the lookup tables from these three variables, you can link them to sliders, as I have done, and then you can see the colors changing continuously as you diddle the sliders. Moreover, if you have an image sequence where the pseudo-color filter doesn't change, the image sequence will be processed very quickly. And the image sequence can be sourced from a relatively fast video camera, like the 60 frame per second video camera built into many laptops. Mine has a little camera at the center. And you can run that through the pseudo-color filter and then make the cool colors. Isn't that cool? So your lookup table gives you a way to do high-performance, low-level image processing. What do you think of that? So is everybody up to speed with lookup tables? I don't want to beat a dead horse. You still don't get the midterm. I was trying to get to the lookup table question.
I think I understand that.
Okay, so now you got that. So the midterm is just like this, only with a difference. And the difference is that the lookup table is rather larger, because you don't have 256 different different colors. You have perhaps intensity max number of colors. What was that? 377 in one case, and maybe larger in some other case. So, what was it? 355. Okay. So if you made this general, then the size of the lookup table would be 2 to the 16, which is 65,536. Then you would have a 16-bit lookup table, and that would work with a 16-bit image. And then only thing you would have to do is populate that lookup table so it maps the 16-bit image into an 8-bit image. How's that grab you? And you wouldn't need to do it for red, green, and blue because it's only a monochrome image. Does that sort of make sense? Did I get everybody up to speed here with the lookup tables? You can see an example where the pseudo-color has been reparameterized if you go to the j2d.gui.main and you run it. And here are the three different parameters that we were mucking about with before. And now you can see what happens when you change them continuously. So, what is pseudo-color? Colors, man. Anybody want to venture a guess? Huh? Made-up colors. Yes, they're false colors. But those false colors might be interesting. Wonder if they could enhance my tear in my knee. Actually, it looks like it just does worse. But pseudo-color is kind of a neat idea because it lets you take certain grayscale values and map them into specific colors. And it is an example of, in this case, homogeneous point processing. What do you think of that? Everybody's so quiet. Yes, we can. Let's take a break.